Hello students and welcome to the AP Chemistry review session. What's going to be happening here today is we're going to go ahead and go over a couple of the problems from the stoichiometry practice because I saw that there were some people that were still struggling with a couple of them, and we can go ahead and go over them right now. So the first problem that we're going to do here is 17a, and the equation for 17a has us working with strontium hydroxide, and it's reacting with hydrochloric acid in this reaction right here. Okay, and it gives us the formula, and it gives us a balanced equation, and it tells us that 25 centimeters cubed of a solution of strontium hydroxide is neutralized by 15 centimeters cubed of 0.1 mole per decimeter hydrochloric acid, blah, 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 blah. Okay, and it's wanting us to go ahead and calculate the concentration of strontium hydroxide solution. Okay, so what we're going to go ahead and do here is we're going to go ahead and say, all right, what do we have? We know in this problem that we have, I guess that I should get a pen. Let's get a good size, and let's go purple. I like purple. Okay, so we know that we have 0.100 moles of NaOH. We also know that we have 15 centimeters cubed of it. And we know that it used up 25 centimeters cubed of the strontium hydroxide. Okay, so this is what we know. Okay, now in every kind of problem, and sorry, this is per decimeter here. And so any time that we have a problem that's like this, where it's using any type of solution, we should go ahead and still think about it as a stoichiometry problem. And our goal for every stoichiometry problem is going to be the same. Okay? And the reason that it's going to be the same is because it's going to follow the same pathways. We're going to try to get to moles, and then from moles we can compare different compounds. So by comparing these, we have to go ahead and get them into moles. So we're going to go ahead and start with the unit that already has moles in it, which is that first unit that we had that was 0.100 moles, and this was over decimeters cubed. Okay, and this is the same thing as moles over liter. So to go ahead and help our brains with it, we're going to go ahead and put liter because that's a better unit anyway. Okay, then what it has us do is it has us use centimeters cubed. And it says that of this compound we have 15 centimeters cubed of it. Okay. Now, centimeters cubed is a volume measurement just like liters is, okay? And it's equal to milliliters, which means that we could take this 15 milliliters and we can convert it to liters, which is be 0.015 liters, okay? And since we have moles on top and we have liters on the bottom here, in order for us to get rid of this liters, what we're going to need to do is multiply it by liters. Okay? Okay. So now, what this will do is this will end up getting rid of our liters, and now we'll be in mole. Okay? Once we're in mole, we can go ahead and figure out, how much we can go ahead and transfer to a different substance. So here, Okay, and here we can go ahead and put the numbers in from our balanced equation. So we can go ahead and verify this here. And our balanced equation is 1 and 2. And then the last thing that we need to do is right here, we're in moles right now. We need to go ahead and get out of moles now, okay? And what it wants is it wants our unit to be in molarity again. So in order to do that, we're going to have to divide by the liters of this, okay? And it gave us the liters of this. It said that we had 0.025 centimeters of this, okay? Or we had 25 centimeters cubed of this. We already did our math before to figure out that that's going to end up being 0.025 liters, okay? From here, we can go ahead and solve. And then what we'll end up getting is 0.03 moles per liter. Okay? And if we happen to be unlucky, it'll be a Cambridge grader, which means I will have to just change this over to moles per dm cubed. Okay? Now, let's go ahead and work on B. Okay? And B is going to be very similar in that it's a molarity problem. And here, it's giving us the volume, and it gives us a molarity of sodium hydroxide. And it says that it's neutralized by this much. Okay? So it's just going the opposite way. It's telling us the same information as the last one. So it's saying that we have this much of a molarity, and that it was used to neutralize this much of a molarity. So let's go ahead and work on through that one. And we'll go ahead and do the same thing. We're going to go ahead and start with the unit that already has moles in it because, why not? And it's 0.400 moles over liters. Then we're going to go ahead and use how much of it that we had. And in this case, it looked like it was 20 centimeters cubed, which we'll go ahead and do the quick conversion, which is just moving it to the 0.02 liters. Then we'll go ahead and do our conversions. And it looks like the NaOH, there were 2 of them. H2SO4. And it said that the total amount of them that we had was 0.02525 liters. Okay? And we can get that because we're doing it the same way. We're going ahead and dividing it by 1,000. And then we do all of our math here, and we will be able to get to our answer. I'm sorry, I forgot to actually solve this one. But at this point, multiplying on the top and dividing by the bottom, you guys should have. Okay. Next, we're going to go ahead and start on number 20. Okay, so now what we will do is go ahead and move on. Let's see. What is this going? Is it still going? All right, so now what we're going to do is go ahead and move on to the next one, which is going to be number 20. I also saw that there were many people that were having issues with number 20. And number 20 is a different kind of a beast here, okay? So number 20 is another example where it's a problem-solving type of issue. And you're going to have to do your best critical thinking here for this. So it's essentially saying that, hey, we have this equation where x is some number, this is added to chlorine, and altogether this makes PlCl3 plus HCl. Alright, and it's saying like, hey, what's the ratio of chlorine to this that we're going to be using? What's the ratio of, what's the actual formula of this here? And then let's balance an equation. And it gives us a couple of pieces of information for it. The first piece is that it takes 50 milliliters of this, and it says that it's a gas, and that reacts perfectly with 150 milliliters of this and 150 and makes 150 milliliters of this. Okay? And so what this is saying is that we have a gas of some sort, and 50 milliliters of this ends up making 150 milliliters of this. And we can go ahead and use the fact that all gases, when they're in a state, have the same amount of moles. So all these gases, 150 milliliters means that there's 3 times as many moles of this gas as there are of this one. Okay? Because volume and number of moles of a gas are going to be equal. And in fact, at room temperature, we divide it by the number of moles, which is 22.4. What we can go ahead and infer, especially because we have H's here and H's here, is that there are 3 times as many H's here. Well, we know that there's the same number of H's in here as there are here. But here, it says that there's 3 times as many. So there's 3 times as many as 1, which is written over here. And because of that, we can infer that because it requires 3 times as many H's, so it takes 150 milliliters instead of 50, that we actually have 3 times the amount of H's as are indicated. So that means that this formula is going to be pH3. And then we would go ahead and add our Cl to that. And that makes PCl3 plus HCl. Okay? Now the next thing that it asks is how many moles of this react with how many moles of this. Okay, well, we'll have to balance the equation here. So here we have 2 and 3. That's like impossible to balance. So we'll have to go ahead and be like, all right, let's balance it out. This is going to have to be a 2. And then this will be a 2. And here this is 6 H's, so 6 over here. Which means 2 times 3, which is going to be 6 plus 6, so that would be 6 here. And we go ahead and notice like, oh wait, no, all of these could be divided by 3, so should it be PHC? Yeah, I'm not sure what kind of cognitive error I had there. 3Cl. And notice we'll have 6Cl here. PCl3 plus 3HCl. Okay, and this means that it's going to take, for that first question, it's going to take 3 moles of Cl to give us 1 mole, to react with 1 mole of PHX. Okay. And that's it for 20 because, we figured out the formula and we balance it out. Right? I hope this video all finds you well, and I hope you have a good one.